Today we're going to learn how to use elimination and substitution. We use these two methods when we're dealing with two variables. So in this equation right here, we see there's an x variable and a y variable. So this is a system in which there are two equations. So we're going to have to find the value of the x and y. So let's start solving this equation using elimination. The goal of elimination is adding or subtracting these two equations so that we make one of the variables disappear. So let's see. Could we add or subtract the 5x and the 6x to make one of them both disappear? Probably not. But could we do that for the y's? Yeah, we can, because if we add negative 2y to positive 2y, it's going to cancel out because it turns into 0. So we need to add these equations. So 5x plus 6x, that's just 11x. Negative 2y plus positive 2y, that's 0. So that's why we added, because it would cancel out to 0. And 17 plus 16, that's just 33. So it's basically just 11x equals 33. And 11 divided by 33, that means the x value here is going to be 3. So we need to find the y value as well. So now that we know that the x value is 3, we just need to plug it into one of these equations. It could be either one. So let's just do the second one. Why not? So since we know the x is 3, we're going to plug that in. Plus 2y. We don't know the y yet, so we're trying to find that out. Equals 16. So 6 times 3 is 18. Plus 2y equals 16. And if we take this here, we move this to isolate the y. That's negative 2 equals 2y. So negative 2 divided by 2 is negative 1. So the y equals negative 1. So let's do another example. There's something different about this equation, though, from the other equation. In this equation, we cannot subtract or add both equations in which one of the variables would be eliminated. So what that means is that we cannot add or subtract the x's or the y's in which they'll equal 0, and we can eliminate it. So we can't add 3x and 2x or subtract it because it won't cancel out and make 0. We can't add or subtract the 2y and 6y because if we can't add it or subtract it to make it equal to 0 and cancel out. So what do we do here? What we could cancel that out is if one of the variables had the same value. So like if this was both equal this, if the x's were both equal to the same thing, we could subtract them, and since they're the same thing, they're going to subtract to 0 and cancel out. But since they're not the same number, how could we do that? So we could do this by multiplying both of the equations by different numbers to make them equal to make the x values have the same value. So did you notice that the 3 and 2 are both common factors of 6? That means if we turn both of them into a 6, we could easily subtract them since they're both 6 and make them cancel out to 0. So how would we do that? We want to turn this x into a 6 and this 2 into a 6. So if we multiply the entire first equation by 2, we can make this into a 6x, but we'll change the entire equation. So let's multiply the first equation by 2. It would be 6x plus 6y, since we multiply the whole equation, equals 18, because 2 times 9 is 18. So we made the first equation into a 6x, but we also have to make the second equation into a 6x. So what will we need to multiply this equation by to get 6x as the x variable? That would be 3. So 3 times this entire equation would be 6x plus 18y equals 18. So now that the x values are the same, we could subtract them and cancel them out. So let's do that. Let's eliminate the x variable by subtracting. So by subtracting these two equations, we will get 18 minus 18 is just 0 equals, this is supposed to be a 4, sorry. 4y minus 18y, that's just negative 14y. And 6x minus 6x, that would just be 0. So we only need to put that. So now we can find the y variable with just this. So negative 14 divided by 0 is just 0. So now we know that the y is equal to 0. Now that we know the value of y, all we have to do is plug it into one of the equations so we can find the x value. It doesn't matter which equation we plug this y into, because we're going to get the same answer even if we do it with this equation or this equation. So let's do it with the first equation. Why not? So we know it's 3x, we don't know the x value, plus 2y, we know the y is 0, so we'll put in that as 0, equals 9. So 2 times 0 here is just 0. So it would just be 3x equals 9. So if we divide that all by 3, we get x equals 3. Now we know that the y value is equal to 0 and the x is equal to 3. We completely solved the equation. So now we're going to move on to substitution. So now we're going to learn how to use substitution. It's a bit different from elimination, but we can use it to solve systems too. So let me show you how it works. So let's look at the first equation here, x plus y equals 3. We could technically rewrite that so it is x equals 3 minus y. We could do this because if we move the y to the other side over here, that's what it would mean. So what can we use with that? So if we know that the x equals 3 minus y, can't we just substitute it in for here? So what I'm saying is, since we know that this is x equals 3 minus y, we could basically just put 3y plus 3 minus y equals 5. Because if this means the same thing as x, why can't we just substitute it? So that's what we do. So now that we could do this, all we have to do is simplify. So if we add this all together, negative y plus 3y is just 2y plus 3 equals 5. And if we take the 3 over here, just move it, it would be 2 equals 2y. That would give us, if we divide, that would be y equals 1. So if we plug the 1 back in here for y, it would just be, running out of space, but x plus 1 equals 3. And that would just be 2 equals x if we move the other side. So now we know that the x is 2 and the y is 1. So here's our other example. In this one, we can't substitute because they don't equal the same thing. We can't substitute a 5x here for a 7x or 4y for a 6y. They need to be the same coefficient. So let's try to get the y's to have the same coefficient, 4 and 6. They're both common factors of the number 12. So what would we need to multiply the first equation to get 12y? That would just be 3. So if we multiply the entire equation by 3, we would get 15x plus 12y equals 66. So for the second equation, what do we need to multiply to get 12y? That would just be 2. Because 2 times 6y is 12y. So that would just be 14x plus 12y equals 64. So, now that we have the equations out, we see that the 12y's are both the same. So let's move the 15x over here so we can isolate this 12y. So it would just be 12y equals 66 minus 15x. So we know that the 12i equals this statement right here. So we could plug this statement in for the other 12y right here. So that would just be 14x plus 66 minus 15x equals 64. So if we simplify that, 14x plus negative 15x is just negative x, plus 66 equals 64. So if we move the 66 to the other side, it would be negative 2 over negative x, which is just x equals 2. So now that we know the x value, we just need to plug into one of the equations and we can get the y value as well. So since the x value is equal to 2, let's just plug it into one of the equations. Let's just do the second one. Why not? So 7 times x, which is 2, plus 6y equals 32. So 7 times 2 is 14 plus 6y is equal to 32. So if we move the 14 to the other side, that would just be 18. So 18 equals 6y. If we divide this all by 6, y is just going to equal 3. So we have the x and y right here. Now we solve the equation.